So now let's look at depth first search algorithm taking place over different graphs as a demonstration over this visualization that we have. Now say we have this graph with us, right? Now I want to start a depth first traversal say from 0, right? So I pick 0 node and let's see how the traversal takes place. So from 0 I went to 1, from 1 I went to 2, back I backtrace to 0, from where I went to 3, and then I cannot move further, I cannot move in any more depth, so I will go back to 0. So let me just explain you the convention that is used in almost any textbook explaining depth first traversal. An unvisited node is represented by a white circle. A traversed node or a visited node is represented by a gray circle, and an explored node which is completely explored. A node is explored when all of its children subtrees are explored completely. So when all of its children are explored completely, we can assign that node a black color. So that is called the explored node, and we are using green color for a highlighted node. That means currently that node is being traversed, right? We also have the various edge types. Okay, so a black edge represents an unvisited edge, a green edge will represent a traverse edge, and a blue edge will represent a completely explored edge which will not be traversed anymore in the graph further on. So let's take a look at another example. Let's start the DFS algorithm from 2. Alright, so starting from 2 we go to 3, from 3 we go to 4, then we can go to 6, and then we have to backtrace to 4, and from 3 we have 5 as a child, and we go to 6. Now that we have explored all the children of 6, we can assign 3 the black color because it's completely explored, and then we come back to 2, and from 2 we have no more other out degrees left which are yet to be explored, and so all the children going from 2 are explored completely, and so we assign the color black to the node 2, right? We can take another look, just observe for yourself. So what we saw in this graph, if we started from node 0, we could visit every other node in the graph and obtain the depth first search traversal for every other node. Now let's look at some demonstration of on the tree structure rather than a graph structure. See, for example, we start at the traversal from 4. Now from 4 we can only go to 5 and 6 because those are the only kids that 4 has. So we cannot visit all the other nodes, which is 0, 1, 3 and 2, right? If we started from say 0, we would have been able to visit every other node in the tree that is there. Right, so let's look at this example. So now that we have explored all the kids of 4, we assign black color to 4, and then 3 and 4 are explored, so 1 becomes black, and 1 and 2 are also explored, so 0 becomes black. So like that we have explored all the edges. Let's run it on one more graph. So as you can see, we have a very good interactive demonstration that will perform the DFS for you and explain all the possible DFS's traversals that are possible on a given graph. So please go through them, kindly go through them, and experiment with all the different nodes. Like for in the same graph, if I started from say node 2, what all edges would have been traversed, what all nodes would have been visited. So that will be very helpful for the learning and betterment of the understanding of the concepts that are associated with DFS.